Okay, so we are going to look at the activities of recursion. Let's start the activity.
Activity 1.
Drag and drop items into the correct bin. So iteration, useless memory. Slower in execution, recursion. Doesn't use a stack for the loop. Faster in execution. Smaller code used to solve a problem. Use more memory. Longer code used to solve a problem. That's iteration. Uses a stack for the loop. Recursion. Yep, that's all correct. Right.
Activity 2.
The following recursive code with blanks shows how to reverse a list element from the linked list. Fill in the blanks. Following recursive code with blanks shows how to reverse a list element from the linked list. Fill in the blank. Okay, so head, when head is equal to, okay, so head is equal to null, return reverse, that's head dot next. Yeah. And then head dot value. Move your cursor to the appropriate blank position, click the help button for the suitable term. Okay, you may try the following. Head. Okay, so that should be head. Yeah. Next, data head preview. Okay, so it should be there. Okay, submit. It's correct. Okay, so basically this is called an untailed recursion, right? So in that the recursive call is not the last call, as you can see. So this is this call. After this call there is a system out println method, right? So this will basically evaluate in reverse when the head becomes null, which is the base case. All right.
Activity 3.
Complete the following Java code function using suitable statements to print the nth Fibonacci number. Okay, so Fibonacci number is basically when it is less than 2, we return the n, right? The base case and the recursive case. Yeah, we know the base case is, so it was going to print the nth, so this is return n. Else it is return Fibonacci n minus 2 and Fibonacci n minus 1. Okay, so it's not given, but this is how you get this. Okay. What does that mean? Fibo. So here it should be Fibo. It's also Fibo. So that's correct. So here return this one. So there you go. Right.
Activity
Okay,
4.
activity 4. The following tree diagram illustrates the recursive mechanism when finding the fifth Fibonacci number. Fill in the blank. Okay, fifth Fibonacci number. So n minus 2 and n minus 1. So this is fib 4. Yeah, fib 5 means fib 4 plus fib 3. So fib 3 plus fib 4, right? So fib 3 is fib 1 and fib 2, right? Okay, so this one is fib fib 0 and fib 1. This is fib 1. This is fib 1. Right? So here when you get fib 0, fib 1, so these will basically hit the base condition, right? So it will return 1. Return 1, here 1, 1, 1, 1, 1, right? So, and then these gets added and returned here, and then these get added and returned here. So it will, the execution will go in reverse and return as well. Okay. Yep. So there you go.
Activity 5.
Consider the following code for non-tail factorial. So yeah, it's an non-tail factorial, right? So here we have the factorial. Non-tail means, as you can see, the factorial call is being made again, but there's a multiplication here, right? So there's a operation done on the recursive call after the recursive call is returned. So this is called, this is not a tail recursion. So because of that, it's a non-tail recursion. Okay. All right, so let's do the question here. A programmer converted the given code into a tail recursion program category with blank. All right, so we have the accumulator, right? So if you go back,
Activity
when
5.
n equals 0 and n equals 1, you should return 1, right? So
You have reached the end of part 1 of the activities of the recursion lesson.
this
Activity
one for
5.
you question. Okay, so for this one, here it is a return 1, right? And here it should be return so it should be again factorial. Return 1, return UCSC accumulator. Minus 1, okay, so here I'm not, okay, so this is correct and this one is wrong, right? So factorial n minus 1 and n into accumulator. So Initially it should be n into accumulator. Okay, should be the answer. Right, so this is as you can see, the factorial function is being called here, right? So after this call there's no operation, right? It's the return call. It's exactly the same as the factorial call but with different parameters. So in a tail recursion function we use an accumulator, right? It's an intermediate uh, variable that holds the results, right?
Page.
Okay, so we are done with this. Exit activity. All right.